Hello everyone and welcome to my YouTube channel, The Physicist. So today we embark on a journey of discovery that bridges the abstract world of solid state physics and quantum mechanics with the practical realm of semiconductor physics. That is, we will see why solid state physics and quantum mechanics are important to study semiconductor physics. Okay, in short, SP, semiconductor physics. So in this video, let us delve into the question of why engineers in fields like CSC, that is computer science and engineering, triple E, that is electrical and electronics engineering, ECE, that is electronics and communication engineering, and AIML, which is artificial intelligence and machine learning, should study solid state physics and quantum mechanics to understand the semiconductor physics along with various application in different industries. Okay, so the question in front of us is that. So the question is why an engineer need to understand semiconductor physics and what is the significance of solid state physics and quantum mechanics in understanding semiconductor physics. Okay, so this is the question that we will delve into, because first unit belongs to, in the course of semiconductor physics, the first unit belongs to the solid state physics and the second and third unit belong to the quantum mechanics and also the their union. Okay, both these two concepts will be taken in unit 3. Okay, in second unit only quantum mechanics will be taught, in first unit only solid state physics will be taught, and in the unit 3 we will combine these two subjects and we take concepts from both of them and we will study the how electrons move into the crystal. Okay, in doing so we will take into consider the quantum behavior of these particles. Okay, so we will see that in unit 3, and in the fourth unit we will study solid state physics. So that's why this question arises: what is the significance of solid state physics and quantum mechanics in understanding the solid state physics, semiconductor physics. Okay, so let us first delve into this part of the question. Okay, so let us discuss about the solid state physics and quantum mechanics. Okay, so solid state physics and quantum mechanics. So in solid state physics we study atomic structure. Okay, atomic structure, and we also study the crystal lattice. Okay, crystal lattice, this we study in solid state physics. And in quantum mechanics we study about the wave functions, okay, the wave properties, dual nature of particles and waves. Okay, both the particles and waves behave as a wave as well as particles. Okay, so this is a dual nature of these these things of nature. Okay, so in quantum mechanics we deal with these things. Okay, we study Schrodinger equation. Okay, which is a second order partial differential equation. So we solve this Schrodinger equation in quantum mechanics and find properties of systems. Okay, and in semiconductor physics we uh, we investigate atomic structure and crystal lattices. Okay, and when these two combines, we study the band theory of solids. Band theory of solids. Okay, so in atomic structure we study the uh, foundation for the understanding the arrangement and behavior of atoms in materials. Okay, we do it in semiconductor physics, which are crucial for the comprehending the semiconductor properties. Okay, so the solid state physics, in which we study atomic structure, this provides a foundation for understanding the arrangement and behavior of atoms where of atoms in materials. Okay, so that we can use these semiconductor materials for our own benefit. Okay, so these things are very, very crucial for comprehending the semiconductor physics. Comprehending semiconductor physics. Okay, we also discuss crystal lattices. So engineers need to grasp the crystal structure and lattice vibrations, which influences the electronic behavior of the semiconductors. Okay, so in band theory of solids, quantum mechanics plays a central role. Quantum mechanics explains energy band formation and the electronic behavior. Okay, like valence and conduction band. So in semiconductor physics we will see that there are two types of bands. One is called conduction band and another is called valence band, like the valence shell in case of atoms. Okay, and this thing here, so this all is conduction band and this all is valence band, and this is the gap. Okay, which is called band gap, energy band gap. Okay, no electron can exist in this energy range. Okay, so it is called energy band gap. Okay, so quantum mechanics also describes the electron states and probability crucial for understanding the transport and energy levels in semiconductor. How the transport in is occurring in the semiconductor, quantum mechanics is very, very important for that, and about the energy levels in semiconductor. Okay, so now let us discuss about the application in various industries. Okay, so what are the applications in various industries? So our next question is, what are the applications of various applications in various industries? Okay, so let us first discuss about the CSC, that is computer science and engineering. Okay, so in CSC you must be familiar with these terms: microprocessors, and CPUs, that is central processing units of computers. Okay, and microprocessors are also used in computers and in other applications. So understanding semiconductor physics is very vital for designing an efficient microprocessor and CPU that are used in computers and mobile devices. So these things are used in computers and mobile devices. So you must which are made from a semiconductor material. So you should know that how the semiconductor physics works, okay, to make these type of devices. Okay, another thing where semiconductor physics is very helpful is memory devices. Memory devices. Okay, so today we know many solid state memory devices, okay, like flash drives and RAM. Okay, RAM, which utilizes the semiconductor physics principles. Okay, and another thing where semiconductor physics, study of semiconductor physics is very important is quantum computing. Okay, so quantum mechanics, which we study in going to study in this uh, course, is essential for developing quantum computers. Okay, so quantum mechanics is essential for developing quantum computers. Quantum computers. Okay, so which leverage quantum states for advanced computations. Okay, in a classical computers we have the binary language 0 and 1. Okay, so a state can be 0 or 1. It cannot be 0 and 1 simultaneously. But in quantum computing or quantum computers, the state can be simultaneously 0 and 1. So that's why it is very, very fast computing. Okay, so quantum computing is very, very important, and understanding semiconductor physics, in which quantum mechanics is also a part, is very, very essential. Okay, the other branch of the engineering is electrical and electronics engineering, that is triple E. Okay, they study about transistors and diodes. Okay, and these are semiconductor devices. Okay, and the transistor is a fundamental component in electronic circuits. Okay, and grasp of semiconductor physics is critical for designing and optimizing transistors. Okay, which is a fundamental component in electronic circuits. Electronic circuits. And diodes can be used as switches or rectifiers. Okay, and they are rectifiers. Okay, they convert AC to DC. Okay, they can be used as switches in one direction. They can let the electron flow, but in the other direction they can hinder the movement of electrons and have high resistance. So one way it is low, they are low resistance device, and on the other way, if the direction of current is changed, they are high resistance devices. Okay, so understanding these components are very, very important, and to understand them, we need to study semiconductor physics. Next important thing which triple E student studies is power electronics. Power electronics. Okay. So some transistors cannot take large powers. Okay. But we can modify them. Okay. And to modify them, we need to understand the semiconductor physics. Okay. And semiconductor devices like thyristor and MOSFETs are used in power electronics applications. Okay. Thyristors and MOSFETs, metal oxide semiconductor, field effect transistors. Okay. So we will study them in details in the unit 4. Okay. So these are used in power electronics. Also the solar cells. Okay. Solar cells are nothing but a semiconductor device. Okay. These are also called photovoltaic cells. Photovoltaic cells. Okay. What does they do? They convert sunlight into electricity. Okay. So convert sunlight into electricity. Okay. And they uses semiconductor material for this. Semiconductor material for this purpose. Okay. So the next branch where we study semiconductor physics in Kurukshetra University is electronics and communication engineering. Okay. They study integrated circuits. Okay. And semiconductor physics underpins the design of integrated circuits that are used in various electronic devices. So this is the main component of our computers, our mobiles, and every electronic systems. Okay. Our TVs. Okay. So integrated circuits are very important to us. Okay. And these are, we can understand them if we can understand diodes, transistors. Okay. And to understand them, we need to do semiconductor physics. Okay. And another branch of ECE where the principle of semiconductor physics are used is called optoelectronics. Okay. Optoelectronics changes the solar cell is also an optoelectronic devices. They changes opto means optical. It comes from optical. Okay. And electronics means electricity. So what optoelectronic devices represent? They represent conversion from optical energy to electricity or electricity to optical energy. Okay. So light can be converted into electricity or electricity can be converted into light. Okay. So devices like LED, which is light emitting diode, and laser diodes. These are the optoelectronic devices and are based on the semiconductor properties of the material. So that's why we need to study semiconductor physics. Another thing is RF devices. Okay. RF devices, which is called the radio frequency devices. Radio frequency. RF means radio frequency devices. RF devices. Okay, transistors and diodes are very crucial in radio frequency circuits, okay, which are used in wireless communication. So they are used in wireless communication. Okay, so now let us discuss about the branch AIML, why they need to study semiconductor physics. Okay, the student who is doing artificial intelligence and machine learning, they need to understand the neuromorphic computing. Okay, they need to understand the neuromorphic computing. Okay, neuromorphic computing. Okay, what is neuromorphic computing? The semiconductor physics is very vital in developing hardware that mimics neural networks. So neuromorphic computing is that computing in which we mimic the neural networks, okay, that are in our brains, neural networks. Okay, for advancing the AI, that is artificial intelligence and machine learning. So for doing the neuromorphic computing, we need to develop some hardwares that mimics the neural network. So if an AIML engineer knows the semiconductor physics, he can very well develop these hardwares or these devices. Okay, sensors. Okay, many sensors like photo detectors and temperature sensors, they rely on semiconductors for signal detection. Okay, so photo detectors and temperature sensors, so they rely on the semiconductor. So okay, so next is quantum machine learning. Quantum machine learning. Okay, quantum machine learning, it plays a role in quantum mechanics. Oh, sorry. The quantum mechanics plays a role in quantum machine learning. Okay, so learning algorithms and quantum neural networks. Quantum neural networks. Okay. Okay, so this is our okay, so that's why an engineer need to understand semiconductor physics. And we also discuss the significance of semiconductor physics, the solid state physics and quantum mechanics in understanding semiconductor physics. Okay, so now let us look at other industries which uses the semiconductor physics concepts, okay, or the semiconductors. So other industries. Okay, these are the medical devices. So medical devices, okay, which are in which the semiconductors are used, like in medical imaging devices. Medical imaging devices, okay, like MRI, CT scans. Okay, CT scans, these are also used in sensors, medical sensors and treatment devices. Treatment devices. Okay, so in medical industry, the semiconductor physics is used and semiconductor materials are used. Also in industry automotive industry. Okay, semiconductor powers the various vehicle systems and from engine control to infotainment. Okay, and renewable energy, another field is renewable energy. Okay, so semiconductors are integral to solar panels and wind turbine control systems. Okay, so these all industries and branches use the semiconductor physics. Okay, so in summary, we can say that solid state physics and quantum mechanics, they form the foundation for understanding the behavior of semiconductors. Okay, which are at the heart of modern technology. All the semiconductors are at the heart of modern technology. Okay, so we should study semiconductor physics. So engineers in CSE, EEE, ECE and AIML need this knowledge to design, optimize and innovate semiconductor based devices and systems that drive progress across a wide range of industries. Okay, so that's about the lecture. So thank you for listening and watching. Please like, subscribe and share the video. Thank you.